20 amps plug on the brewer is likely due to the National Electrical Code, referred to as NEC, requirement that appliances drawing more than 15 amps have a cord and plug rated for the maximum load. Even though the brewer draws 18 amps, it may not be considered a continuous load. It is important to know the difference between continuous versus non-continuous loads. A continuous load is one that operates for extended periods of time without being turned off. Examples include lighting, refrigerators, and motors. A non-continuous load is one that operates for limited periods of time, such as a toaster, space heater, or tea brewer. For non-continuous loads, the NEC allows the use of a cord and plug rated for less than the maximum load, provided that the load is not subjected to continuous operation. This is because the load will not draw its maximum current for an extended period of time. So in this case, the tea brewer is a non-continuous load. Even though it draws 18 amps, it is not expected to operate continuously for extended periods. Therefore, the following options are acceptable. Firstly, use the provided 20 amps plug and cord because the brewer manufacturer has determined that the 20 amps plug and cord are sufficient for the brewer's load. Secondly, install a 30 amp circuit with a 20 amps plug. This option provides additional protection and complies with the NEC requirement for a 30 amp circuit for loads drawing 18 amps or more. It is recommended to install a 30 amp circuit with a 20 amps plug. This provides the necessary protection for the circuit while still allowing the use of the brewer's provided cord and plug. The NEC defines a continuous load as a load where the maximum current is expected to continue for 3 hours or more. For continuous loads, the overcurrent protection device, such as a circuit breaker, should be rated for not less than 125% of the continuous load. In this situation, the tea brewer is considered a non-continuous load. Therefore, the overcurrent protection device should be rated for at least the non-continuous load, which is 18 amps. In general, electrical circuits are designed to handle specific amounts of current measured in amps. Exceeding the current capacity of a circuit can lead to overheating, which can cause insulation to melt or even start a fire. The National Electrical Code provides guidelines for safe electrical installations, including the proper sizing of circuits and overcurrent protection devices like circuit breakers and fuses. The size of a circuit is determined by the amperage rating of its overcurrent protection device. For example, a 20 amp circuit is protected by a 20 amp circuit breaker. The ampacity of a conductor or wire is the maximum amount of current it can safely carry. The NEC provides tables that list the ampacity of different sizes and types of conductors. When selecting a conductor for a particular circuit, it's essential to choose one with an ampacity equal to or greater than the circuit's overcurrent protection device. Receptacles, also known as outlets, are the points where electrical power is drawn from a circuit to supply devices and appliances. Receptacles come in various amperage and voltage ratings, and it's crucial to use the correct type for the intended application. For instance, a standard household receptacle is typically rated for 15 amps at 120 volts, while a heavy-duty receptacle for a high-power appliance like a dryer might be rated for 30 amps at 240 volts. Plugs are the connecting devices that are attached to the end of a cord and are inserted into receptacles to establish an electrical connection. Like receptacles, plugs are also rated for specific amperages and voltages. The plug's rating should match the rating of the receptacle it's intended to be used with, as well as the current requirements of the appliance or device it's connected to. Using a plug with a lower amperage rating than the appliance requires can lead to overheating and potential hazards. When dealing with electrical circuits and equipment, it's essential to understand the concept of voltage drop, which is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause appliances and devices to operate inefficiently or even malfunction. The NEC provides guidelines for minimizing voltage drop by selecting appropriate conductor sizes and minimizing the length of circuit runs. Grounding is a critical safety measure in electrical systems, providing a low resistance path for fault currents to flow back to the source in the event of a short circuit. A properly grounded system helps to prevent electrical shock hazards and minimizes the risk of fire. The NEC mandates specific grounding requirements for various types of electrical installations, ensuring that all conductive materials that could potentially become energized are properly grounded. Arc fault circuit interrupters, referred to as FSIs, are devices designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. Arc faults can occur due to damaged or deteriorated wiring, loose connections, or insulation breakdown. FSIs trip a circuit breaker when they detect an arc fault, interrupting the flow of electricity and preventing a fire from starting. The NEC requires FSIs in many areas of a home, particularly in bedrooms, living rooms, and other areas where arc faults are more likely to occur. Ground fault circuit interrupters, referred to as GFCIs, are devices designed to protect people from electrical shock hazards. GFCIs monitor the current flowing through a circuit and quickly interrupt the power if they detect a ground fault, which is a condition where current leaks to ground through an unintended path, such as a person's body. The NEC requires GFCIs in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. Electrical panels, also known as breaker boxes or load centers, are the central distribution points for electricity in a building. They house the circuit breakers that protect individual circuits from overloads and short circuits. Electrical panels come in various sizes and configurations, and it's essential to choose a panel with sufficient capacity to accommodate all of the circuits needed for the building's electrical load. When working with electrical panels, it's crucial to follow safety precautions such as turning off the main breaker before working inside the panel. Conduit is a protective tubing used to enclose electrical wiring, providing physical protection and preventing damage from moisture, chemicals, and other environmental factors. Conduit is available in various materials, including metal, PVC, and flexible types, each suited for different applications. The NEC specifies the types of conduit that are permitted for use in various locations and conditions. Wiring methods refer to the techniques and materials used to install electrical wiring in a building. Common wiring methods include non-metallic sheet cable, also known as Romex, which is widely used for residential wiring, and electrical metallic tubing, referred to as EMT, which is often used for commercial and industrial applications. The NEC specifies the requirements for various wiring methods, including the types of conductors, supports, and connections that are permitted. Junction boxes are enclosures used to house electrical connections, providing a safe and organized way to splice wires and terminate circuits. Junction boxes must be accessible for inspection and maintenance and must be sized appropriately to accommodate the number and size of conductors inside. The NEC specifies the requirements for junction boxes, including the materials, dimensions, and installation methods that are permitted. Electrical codes are sets of regulations that govern the safe installation and maintenance of electrical systems. The most widely adopted electrical code in the United States is the National Electrical Code, which is developed by the National Fire Protection Association. Electrical codes are updated periodically to reflect changes in technology and best practices, and it's essential for electricians and other electrical professionals to stay up to date with the latest code requirements. Electrical safety is paramount when working with electricity, and it's essential to follow safe work practices to prevent electrical shock, burns, and other injuries. Some essential safety precautions include energizing circuits before working on them, using insulated tools and equipment, wearing appropriate personal protective equipment, and following lockout/tagout procedures to prevent accidental energization of circuits. Electrical testing is an important part of electrical maintenance and troubleshooting. Various types of electrical tests can be performed to assess the condition of electrical equipment and identify potential problems. Some common electrical tests include voltage tests, continuity tests, insulation resistance tests, and ground impedance tests. The results of electrical tests can be used to diagnose electrical problems and ensure that electrical systems are operating safely and efficiently. Electrical troubleshooting is the process of identifying and resolving electrical problems. Troubleshooting electrical problems requires a systematic approach, including gathering information, testing circuits and components, and analyzing the results to determine the root cause of the problem. Electrical troubleshooting often involves the use of specialized tools and equipment such as multimeters, clamp-on ammeters, and circuit tracers. Electrical maintenance is the practice of regularly inspecting, testing, and servicing electrical equipment to ensure that it is operating safely and efficiently. Electrical maintenance can help to prevent breakdowns, extend the lifespan of electrical equipment, and improve overall system reliability. Electrical maintenance tasks may include cleaning and tightening connections, inspecting for damage or wear, testing installation resistance, and calibrating protective devices. The NEC Table 310.15, formerly 310.16, provides ampacity ratings for conductors based on insulation type and temperature rating. This table is crucial for selecting the correct wire size for a given electrical load. Always consult the latest version of the NEC for the most up-to-date information. Proper grounding is essential for electrical safety. It provides a low impedance path for fault current to return to the source, minimizing the risk of electric shock. Grounding electrodes, grounding conductors, and bonding jumpers are all part of a complete grounding system. Understanding how these components work together is crucial for creating a safe electrical installation. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. When the current in a circuit exceeds the rating of the overcurrent protection device, it will trip or blow, interrupting the flow of electricity and preventing damage to the circuit. Selecting the correct overcurrent protection device for a given circuit is crucial for ensuring electrical safety. Short circuit current rating, referred to as SCCR, is the maximum amount of fault current that an electrical component or system can safely withstand without failure. It is important to ensure that all electrical components in a system have an SCCR that is equal to or greater than the available fault current at their point of installation. This helps to prevent equipment damage and electrical hazards in the event of a short circuit. A wiring diagram is a visual representation of an electrical circuit showing the components and connections in a clear and organized manner. Wiring diagrams are essential for installing, troubleshooting, and maintaining electrical systems. There are different types of wiring diagrams, including schematic diagrams, ladder diagrams, and point-to-point diagrams. Understanding how to read and interpret wiring diagrams is a valuable skill for anyone working with electricity. Electrical permits are required for many types of electrical work, including new installations, renovations, and repairs. Obtaining an electrical permit ensures that the work will be inspected by a qualified electrical inspector to verify that it complies with the NEC and other applicable codes and standards. Electrical inspections are conducted by qualified electrical inspectors to verify that electrical work complies with the NEC and other applicable codes and standards. Electrical inspections help to ensure that electrical systems are installed safely and correctly, minimizing the risk of electrical hazards. If electrical work fails an inspection, the contractor or homeowner will be required to correct the deficiencies before the system can be energized. The neutral conductor is a current-carrying conductor in an alternating current, referred to as AC, electrical system that is normally at or near 0 volts potential with respect to ground. The neutral conductor provides a return path for current from the load back to the source. In a properly functioning electrical system, the neutral conductor should only carry current that is due to imbalanced loads. The equipment grounding conductor, often referred to as EGC, is a safety conductor that provides a low impedance path for fault current to return to the source. The EGC is connected to the metal enclosures of electrical equipment and appliances and is bonded to the grounding electrode system. The EGC helps to prevent electrical shock hazards by ensuring that metal parts of electrical equipment do not become energized in the event of a fault. A multi-wire branch circuit, often referred to as MWBC, is a type of electrical circuit that shares a common neutral conductor between two or more hot conductors. MWBCs can be used to save on wiring costs and reduce voltage drop. However, it is important to ensure that the neutral conductor is properly sized to handle the combined load of all the hot conductors. An isolated ground receptacle is a type of electrical receptacle that has a separate grounding conductor that is isolated from the normal equipment grounding system. Isolated ground receptacles are often used in sensitive electronic equipment to reduce electrical noise and interference. Surge protection devices, referred to as SPD, are designed to protect electrical equipment from voltage surges, such as those caused by lightning strikes or utility switching operations. SPD divert excess voltage away from sensitive equipment, preventing damage and downtime. There are different types of SPD, including whole-house surge protectors and point-of-view surge protectors. A transfer switch is a device that allows you to switch between two different power sources, such as utility power and generator power. Transfer switches are often used in backup power systems to provide a seamless transition to generator power in the event of a power outage. There are two main types of transfer switches: manual transfer switches and automatic transfer switches. A generator is a device that converts mechanical energy into electrical energy. Generators are often used as backup power sources in homes and businesses. There are different types of generators, including portable generators and standby generators. Standby generators are permanently installed and can automatically start up in the event of a power outage. Uninterruptible power supplies, often referred to as UPS, are devices that provide backup power to critical equipment in the event of a power outage. UPS typically use batteries to store energy and can provide power for a limited time depending on the size of the battery and the load connected to the UPS. UPS are often used to protect computers, servers, and other sensitive electronic equipment from data loss or damage due to power outages. Harmonic distortion is a type of electrical pollution that can be caused by nonlinear loads such as electronic ballasts and variable frequency drives. Harmonic distortion can cause overheating of electrical equipment, voltage distortion, and other problems. There are various methods for mitigating harmonic distortion, including the use of harmonic filters and line reactors. Power factor is a measure of how efficiently electrical power is being used. A power factor of 1.0 indicates that all of the power being supplied to a load is being used to do useful work. A power factor of less than 1.0 indicates that some of the power is being wasted. Low power factor can cause increased energy costs and reduce system capacity. There are various methods for improving power factor, including the use of power factor correction capacitors. Electrical safety audits are conducted to identify potential electrical hazards and ensure that electrical systems are in compliance with applicable codes and standards. Electrical safety audits can help to prevent accidents, reduce the risk of fire, and improve overall system safety. Electrical safety training is essential for anyone who works with electricity. Electrical safety training can help to prevent accidents, reduce the risk of injury, and improve overall system safety. Electrical safety training should cover topics such as electrical hazards, safe work practices, lockout/tagout procedures, and the proper use of personal protective equipment. The NEC Article 210 covers branch circuits. Article 210.21 covers the permissible loads, while 210.23 covers the maximum loads. 210.24 covers the requirements of the branch circuit. Article 220 provides requirements for calculating branch circuit, feeder, and service loads. Article 230 covers service entrance. This includes overhead and underground conductors, equipment, and metering. Article 240 covers overcurrent protection. The purpose is to protect equipment, conductors, and overcurrent devices. Article 250 is about grounding and bonding. This ensures a low impedance path for fault current and reduces shock hazards.